Hello, hello, hello. Good morning. Can you guys hear me?
Yeah.
Okay, good. Just I said good morning and nobody even looked or responded or anything. It was terrifying. Kate, I love your cat on your bed. Very cute.
Some kids scared him last week, and I found him hiding behind the washer.
There we go.
Very
Got the
odd.
camera
Something scared him.
working.
You don't know what?
It was the kids outside
Got it.
laughing about it, and I felt really bad.
Yeah. Cats are funny when they get scared though, so it's hard not to laugh at them, right? Bobby, how are you doing?
I'm doing well. I had a good weekend, got a lot of productive stuff done for my own classes. I'm feeling good.
Nice. You're getting close to being done then, right?
Yeah, the semester for NAU ends end of November. So even before MCC semester ends.
Yeah. Good morning, everyone. Everybody's so quiet today. Are you guys tired? Tired of math? Just kidding. I know you couldn't be tired of that. Did everybody get registered for next semester? I hope. Good. If you haven't registered, make sure you do fairly quickly just to get it all handled. Did anybody do anything fun this weekend?
No, I didn't do anything fun.
Yeah, I didn't think I did anything fun either. Although I was on my family Zoom call and I did get to see the twins that are just so freaking cute. So my sister is just loving it. So first time grandma, and she, thank goodness there's two babies, so she can hold one at all times. So she'll have been there like almost 2 months. At the end of this month, she's coming back to Arizona on October 28th, and then she's going back there for Thanksgiving. So she said she's not sure she can come back to Arizona. She doesn't miss her house at all. She says she'll just stay in Connecticut. All right. So today we're not really doing a mindfulness activity, but it's something that I want to remind you to be mindful of. Okay. So especially as you think about doing this for a whole nother semester, depending on how your classes are and what you're taking. I'm going to share my screen. This is something that our Disability Resource Services came out with last week, and I thought it was a good reminder for all of us. Bobby, can you let Clementine in?
Just did.
Thank you. So we're going to continue with probability. We're still in PC4. We're going to do conditional probability today, which is where some people struggle a little bit. So make sure you take good notes. If you need anything, let me know. So this is technology tips on giving your eyes a break. So I don't know about you guys, but I am in front of the screen way more than I was before. I should probably have my glasses on right now. But here's some resources for you. If you've never tried voice typing, that might be helpful. So you're not staring at the screen while you're doing it. Voice dictation on Mac, and they have all these different choices for you. They say if you need this for long term, they say Dragon Naturally Speaking is good. So it's not free, but if you need it for the long term, it might be worth it, and you can get it at a student rate. They also have screen lighting. They talk about using software such as f.lux. I don't know how you're supposed to say that, but
Flux.
I didn't know if it was. Do you think it's just Flux? Why is that dot there?
I don't know. I think it's there because of they're edgy, but I use Flux on my screen and I can personally recommend it. It's great.
Nice. And is Flux free, Bobby?
Yeah, at least it was when I downloaded it. I'm pretty sure it still is, but it's great. All it does is it keeps you from having to stare into a light, like a flashlight all day.
Right.
It dims the screen as the evening comes on. It helps you transition to sleep a little bit better. It's great.
Nice.
It's really good.
Nice. And then, so they say if you have Windows 10, you can look at your display settings just to soften your lights, and then they tell you how to change your brightness on your Mac as well. Text-to-speech Kurzweil Reader is free for all Maricopa students. You just have to set up a username and password at this website. So this link is in our slides that I'll post after class. And so they have all kinds of choices. So anyway, if you've been having trouble or you've noticed you're having a lot more eye strain, it might be just due to you being on the computer more often. So you should, consider making some adjustments because your eyes are very important for you in the long term, and eye strain cannot, it can cause headaches. It can cause lots of other problems. So any questions, concerns? All right, let's do this warm up. Get your answer ready in the chat. You guys can see my screen, yes? Thank goodness.
Yep.
I thought I was just talking to nobody for a minute there. So 2 cards are drawn from a standard deck of cards. What's the probability of drawing a king, putting it back, and then drawing a queen? So calculate that probability. You can use fraction, decimal, or percent and get it ready in the chat. And then about 1 minute, I will have you hit go, but not yet.
should we be reducing the fractions before we start that process? Okay, thank you.
I think it's a lot easier. All right, are you ready with your answer? Let's do it in the chat. You ready? 3, 2, 1, go. Nice. Some of you aren't answering in the chat. I'm not sure why not. So remember, when we're doing these independent events, and we know they're independent because we put the cards back, we multiply the two probabilities. So the probability of drawing a king is 1 out of 13, and the probability of drawing a queen is 1 out of 13. But the answer to the question is the product of those two. You need to multiply them together and get 1 over 169, or there it is as a decimal. And some of you, I know, were deciding where would you round to. So you can see all my work there. So the likelihood is not very high, right? Okay, any questions on that? All right, so conditional probability is required a lot of times when you're calculating the probability that something's going to occur given that something else occurred. Okay, so that's the condition. So the probability that event B occurs given that probability A has happened is represented like that. So notice it has the B first, but that doesn't mean the B happened first. After the line, what's happening after that, that's the condition. So you're trying to figure out the probability that B is happening given that line we read as given that A already happened. Okay, so that's what conditional probability is. And you have to be real careful and make sure you're reading that correctly, because some people get it backwards. Okay. Okay, so we're going to do some problems. I'm going to put this doc in the chat for you, maybe.
Can I ask a question about that? About
yes,
the definition we just went over?
Yeah.
So where it says probability of B given A, does that mean that's the thing that's always to the right of that bar is the first event? Because it's, okay, just making sure,
Yes.
because I got confused with the homework last night.
Yes, absolutely. It is tricky because it seems backwards, but yes, it's saying that you're finding the probability of the new thing happening, which is the first one listed, given that the one after the line already happened. Okay, so there's your new doc in the chat. And this is the first example on that doc. So we're going to do that together. If you want to make a copy of that doc, if you're just writing on paper, whatever, you could do that. Okay. So we're going to make sense of this problem together. So then when you do them on your own, you're not really stuck. Okay. So a jar contains 5 red marbles numbered 1 to 5 and 8 blue marbles numbered 1 to 8. A marble is drawn at random from the jar. Find the probability that the marble is, and then you have 2 questions. Part A says even numbered, given the marble is red. So if we're going to do that problem, first let's write the probability statement that we're looking for. Okay. So we're trying to find the probability that it's even. Whoops. I don't know why that went crazy. Given, do you see that line? That it's red. So the probability is even given that it's red. So we could draw a picture of what this looks like, right? So we have 5 red marbles, and they are numbered 1 to 5. And then we have 8 blue marbles that are numbered 1 to 8. Okay, so I'm going to answer this question when it says the probability that it's even numbered given it's red. So the first condition is exactly what Sydney described. It's the one after the line. So I want to look at only the red marbles. So I'm only going to look at these. Okay, so there's 5 total. How many of them are even? There's 2 of them that are even. So the probability of an even that's red is 2 out of 5, which is the same as 0.4, which is the same as 40%. Any questions on how I did that problem? Are you okay?
I have a question.
Yes.
So when it's just asking about the red marbles, you're only going to take the total number of red marbles and you don't have to look at the blue marbles for that.
Yes.
So like it wouldn't be 13, it would just be 5.
Exactly, because of that line where it says after the line, it says given that it's red. So once we see that condition that it's red, we're not going to count the blue marbles at all. Good question. Okay, so now look at the second part. You're like, it's the same question. It's not the same question. So it's saying, what's the probability that it's red given that it's even? Do you see how that's a different question? So instead of only looking at the red marbles, we're going to look at all the marbles, all the even numbered marbles, and then we're going to see what part of the even number marbles are red. Okay, so this time on the second one, I'm only looking at even marbles. So I'm looking at this 2, this red 4, then I'm looking at the blue 2, the blue 4, the blue 6, and the blue 8. So there's a total of 1, 2, 3, 4, 5, 6. And how many of those are red? There's 2 out of 6 that are red, which is 1/3, which is 0.3 repeating, or 33.33%. Questions on how I figured that out? These are a little bit different. Everybody okay? All right, let's look at the next one together. By the way, you'll see if you review these slides later, you'll see all my examples are up there. So suppose that a math class contains 25 students, 14 of those are females, 3 of whom speak French, and then 11 males, 2 of whom speak French. So part A says compute the probability that a randomly selected student speaks French given that the student is female. So can someone tell me how I would write the probability statement? Just the probability statement. What would I write in those parentheses? Francisco, what would I write in those parentheses?
Wouldn't you put female and then French, or no?
So I am definitely going to put French and female in there, but which one comes before the line and where's the condition? The condition goes after the line. So what
It
are they
would
telling me? Given the student is,
Female. and then
okay, so where would that go?
the first one before the line?
Female goes here?
Yeah, and then the French on that side. Correct or no?
What do you guys think? Do you agree, disagree? What do you think? Kate's shaking her head no.
I think
Okay.
it would be flipped.
It would be flipped. Why would it be flipped?
Because the line translates to given, and in the sentence it says, compute the probability that a randomly selected student speaks French, given, or the line female.
Sorry, the dogs are going nuts today. So Caitlin explained it very nicely. The line means given. So we would write it this way. The probability that the student is French, given that they're female. Francisca, does that make sense why we would switch that order?
Yeah.
Okay, good. Excellent. So now, this one might be a little bit harder for you. So first, we only want to look at the students that are female, right? So how many students are female in this problem?
There's 14.
There's 14 total, so that's going to be our denominator. Now, how many of those speak French?
3.
3. Very nice. Okay, so now you try the next one, and then we'll look at our answers, okay? What do you think? Do you think you got it? You're like, oh, I don't know. Let's see. So that was our answer from the first one. Here's our answer to the second one. Did you get 2 out of 5? How many of you got that? Caitlin gave me a thumbs up. Kate, Zevi, Andrew, Ben, excellent. Jonathan, very nice. Can you see my explanation there? So first you had to figure out, it says the probability that a selected student is male given that they speak French. So you had to find out how many total speak French, which was only 5. Out of all of them, only 5 of them speak French. And then only 2 of them are males. So it would be 2 out of 5. What do you think? Is that okay? Any questions on that? All right. So you have another one that's a table on the next one. You're going to have to read that one very carefully. I think you can do it. I'm trying to decide if we should do it together, but the dogs are driving me nuts, so I feel bad. Let's talk through it because then I have some other work for you to do as well. And so I want to make sure you have time to try that. Okay. All right. So let's read through this next question. Oh, unless there's any questions over the other one. Anybody have any questions over the other one? They're only quiet when I stop talking, just in case you're wondering. Okay, so the next question says a test was given to a group of students. The grades and gender are summarized in the table. Find the probability that the student was male given they earned an A, and then find the probability that the student earned a B given they were female. So let's try to write our probability statement again. So the probability of something given something. What would I write there? Sine, what would I write in those blanks? Oh, you're muted.
Oh, okay. Can you hear me?
Yes, now I can.
Okay. Is it the probability of the male and female?
So it's male, given they earned an A. So I'm going to write male.
Okay. Which would be 10.
All right. So let's just get our statement first, and then let's figure it out. So male, given that they got an A, do you see all of these people got an A?
Mm-hmm.
Do you agree with that? So how many total people got an A?
26.
26. So that's going to be our denominator because that's how many people got an A. Now, tell me about the 10, Sine.
Since it asked how many of the males earned an A, it would be 10.
Very nice, because it's 10 out of 26. And then you can simplify that. So that'd be 5 out of 13. And then you could write it as a decimal if you want. So do you see how you need to read this chart?
Mm-hmm.
Yeah. Excellent. Good job. All right. Now you guys try the second one on your own. We'll do this one as a 3, 2, 1 chat. And can you just leave it a fraction? You could do it a decimal or a percent. I don't care. So, but a fraction is pretty nice in that one. So write your probability statement and then calculate it. All right, are you guys ready? I want to see one from everybody. Even if it's wrong, it's fine. Nobody cares, right? We just are all trying to learn the same thing. If we make a mistake, that's good because then we won't make the mistake on our test, right? Okay, get it ready in the chat. 3, 2, 1, go. All right, Bobby, do you want to explain this one for me?
Sure. This question says, find the probability that the student earned a B given that they were female. So when we're writing our probability statement, B, then we use our vertical line for given and female on the right. So now the way that I kind of look at this given, when we have a problem that says given, is that the female, the number of females, the total number of females is going to be my new denominator. So now I have this table and there's a lot of data in this table, but I'm going to zoom my focus in to the row that's describing the female demographic here. So I'm looking at the highlighted row and I'm seeing that the total is 31. My new denominator is going to be out of 31. Then I can look and see, well, what am I looking at? What would we be happy with this probability? We're looking for women who got a B on this test. So I go to the column that describes the test grade of B, and I see that that's 6. So my numerator is going to be the 6 women who got a B out of the 31. And if you calculate this on your calculator, you can get a decimal of 0.1935. So about 19.4%. So that's highlighting it like that is really helpful because where they intersect is my numerator. The pink highlighted row and the green highlighted column, where those overlap is my new numerator.
Nice, thank you, Bobby. Okay, so did you see where you guys went wrong in your thinking if you were incorrect? It's hard when we give us more data than we need in the table, right? But using that highlighting technique, it might help you. Just if you can't see it, then you might have a problem. All right, so, and then I show you that on the next slide. So any questions on that? So conditional probability is just that. They're putting a condition on it. So they draw that line and say, given something happened. Now, sometimes they get a little tricky in their givens and it does, whatever happened before doesn't actually matter, which is a little confusing. So for example, if they tell you like a coin is flipped twice, what's the probability that you get heads if you got tails on your first one? So that's a condition, but those are independent events. So I don't care what happened on the first one. Does that make sense? So you have to be careful, even though sometimes it sounds like a condition, if they're independent events, you don't have to worry about it, like a coin flip or a dice roll, those kind of things, okay? Okay, so now I put you in breakout rooms. I'm gonna put a new doc in the chat for you to practice with your team. And today I'm gonna make it a little bit different because I'm gonna put you in your smaller teams, but then I'm going to match you up with your larger teams so then you can compare your answers. So there's the new doc, okay? And it's called PC4 Practice Problems, Independent Events, and Conditional Probability. You're gonna see that now we're trying to put two pieces together. So the first few problems are independent problems, which we did last week on Thursday. And then the new ones are this conditional probability. So if you're struggling or you want to practice what we just learned, you'll see on the worksheet where it says Independent events are first, they're problems 1, 2, and 3, but then conditional probability is the second page, problems 4 through 7. So if you want to start with the second page, that's totally fine. Okay. All right. So did you get that, Doc? Excellent. I'm going to put you in your breakout rooms, and then Bobby and I will come visit you. And make sure you ask for help if you need it or if you're finished so we can check your answers. Sine, I put you with room 1 because Mackenzie's not here, so it's your whole team. Caitlin and Leslie are in there with you.
How things going today, AJ?
You might be frozen, I don't know.
Maybe.
Bobby, I'm going to start you in room 8, which is Maddie and Annie.
Okay,
and
perfect.
then you can move your way up. Hello, everyone. Well, everybody's almost back. You guys did awesome today. I'm going to get a check-in from Bobby on a couple of rooms that I didn't visit. And there's your exit ticket. I'll put it in the chat in just a second. All right, welcome back. My room has made great progress. Bobby, can you report the same? Excellent.
Yes, all the rooms I met with were improving. They were asking really good questions and making better
Great.
sense of it, so that the homework will be much easier.
Excellent. Okay, and remember, we're going to spend time on this tomorrow as well. If you didn't finish, please finish. There's your exit ticket in the chat. Please let me know if that link works. My computer is having some sort of freak out moment. Your more PC4 practice is due by tomorrow night. And then we're going to have a quiz on Thursday. Yay! So I also have a review that I posted on Canvas for you. Okay, so the review is on Canvas for you to practice. And the quiz, you'll have the whole class period on Thursday for the quiz, and it's only over 4-1 to 4-4. So tomorrow we're going to finish up 4-4. Wednesday we're going to practice and going over that review, and then Thursday you have your quiz. And it is with a lockdown browser again. So whoever had trouble with a lockdown browser needs to contact me, right? So we make sure we get an appointment set up for you if you need it. Okay? All right. Once you finish your exit ticket, you're set to go. Good job, guys.
I really liked today's work. Our group was really great.
Same here. It actually
Yay.
made sense.
Excellent. And did you like maybe meeting up with your other half of your group, for those of you who did that?
Oh, yes.
We'll do that more too.
3E was like making me burn brain cells, but you know.
Well, it's just, sometimes it's just the wording, right?
Yeah.
Yeah.
I'm
So that's
really
it.
stuck on this exit ticket for some reason.
Well, let me look at it. It's okay if you do it wrong, right? It's not a problem.
Yeah.
Let me go to it real quick. Everything on my screen just froze, which is super duper fun. Right? My computer needs a nap or something. Hold on, let me go there on here. I do not want to sign in. Why did it want me to sign in? I can be anonymous on my own exit ticket, right? I can't even type right now. Hold on, let me go back.
So is it the picture that's confusing you?
No.
Okay, good. Because the picture is not a direct representation of this question.
Okay, so a jar contains 2 red dice numbered 1 to 6, a green dice numbered 1 to 6. A dice is chosen at random from the jar. Find the probability that the die is an even number die, given that it's red. I don't even know what that means.
I'm confused on, so given that it's red, so our denominator is going to be red.
Right, which is 2. There's only 2 that are red, right?
Yes. And then our numerator is going to be even numbers, right?
Yeah, so
Between
here's
1,
what
2,
I
and
think
6.
happened. Let me look at my exit ticket on my slide because it might make more sense. A jar contains 2 red die, blah, blah, blah. Yeah, I know I didn't do this exit ticket before. So you picked, half of the numbers on the die are even. So I would just say 1/2, but that's a terribly worded question, just in case you're wondering. So if you're confused, I am too. I will be fixing that right now because that's, I mean, I guess you could say if you took the dice out and rolled it, right? What's the probability that it's even? But that's a dumb question.
So it's not 3/2?
No. I mean, the way the question is worded doesn't make any sense. So I would just put whatever. Just put nonsensical exit ticket because that's what happened today.
Okay.
Okay.
Bye. Thank you.
Bye. You can just put duh to your teacher, right? That would be fine too. I'm fine with that.
Like we were feeling so good about it, and then the exit ticket.
Yeah, well, as soon as I read the exit ticket, I was like, what is happening right now? Like, who wrote this? I did not this once. I will admit it. I didn't write it. So,
Bye.
All right. See you later, guys.
Elizabeth, how are you feeling?
I'm doing good.
Good.
Good. Excellent. Yeah, don't even worry about that exit ticket. I don't know what happened there. I guess maybe we could say, find the probability that you roll an even number on that die, but that still wouldn't make any sense because
Still half, right? Like out of the 12
well,
numbers that are on the red die, half of them are even numbers.
Right, but a die is chosen at random from the jar. Find the probability that the die is an even numbered die. What does that even mean?
They all have even numbers on. They all have 6 numbers on them, so 100%.
Right, like does one of the dies only contain even numbers and the other one contains odd numbers? I don't know. That one doesn't make any sense to me.
Right? They didn't even need to tell you that there was a green die in there at all.
Yeah, I don't understand what they were getting at with this one. All right, so no worries. Elizabeth, I hope your meeting goes well.